So in this PoC we're going to be covering SD-WAN with complementary virtualized functions, and we're going to be showing this with a carrier Ethernet underlay. A number of vendors are involved in this PoC. That includes Telia, that is the service provider, Kvantel, that's the wholesale provider. So we're actually talking about two service providers, so it's a multi-service provider environment. We then have Nuage, which is going to be providing the SD-WAN portion of this. OneAccess, which is the NID for the layer 2 service, including capabilities for Ethernet over 4G mobile infrastructure. And then RAD, which is the UCPE, that also has NID capabilities, but its main function here is to act as a UCPE hosting the Nuage SD-WAN VNF and also service chaining a firewall VNF. So the goals of this PoC are, firstly, to show that we can use these recently introduced MEF APIs, MEF LSO APIs, and this allows us to do both the multi-vendor interoperability, but also support a range of access technologies. From a service provider point of view, the goal is revenue at the end of the day, right? So we're showing that how Telia can use MEF3 services to extend their network beyond Finland and Sweden and deliver services that also span several Nordic countries. And then from Kvantel, who is the wholesaler, from their perspective, we're going to be showing them providing wholesale e-access services in Norway. The last thing that we did here in 2017 is kind of in the year of SD-WAN. And so the MEF put together a white paper with a broad range of use cases. This PoC actually encompasses all of those SD-WAN use cases. As far as how this PoC innovates, as I said, it implements all those use cases described in the recent MEF white paper. Extensive underlay and overlay service assurance capabilities. So what we show here is when the service orchestrator will first provision the devices, and then we will test, because you've got to confirm that it's working well. And then they're doing that with standard LSO APIs and on-demand CE2O. So that's one of the beauties of this type of solution. We also, because both the NID, the wholesale NID, as well as the UCPE support NID capabilities, CE2O, we can also, it's e-transit ready. So not only e-access, but also e-transit. So this is what it looks like. Here's Telia, the service provider, Kvantel providing the off-net services, the wholesale services. We have here the NIDs, and this is all part of the carrier Ethernet underlay. Provisioned then by the service orchestration. Okay? And then we see the second part of this is the SD-WAN. On the one side we show the SD-WAN running as a physical network function, so it's running basically, Nuage is running on bare metal. On the other side we're showing that the SD-WAN VNF is running on the UCPE as a VNF, and then also service chained with a third party, another VNF, in this case a firewall. And this is really important because SD-WAN has evolved from being the appliance to being, let's sell it to customers who are going to say, wait a minute, I want my own firewall because that's dealing with security concerns. I'm the networking guy, I don't want to mess with what the security guys have put into place. So it's very important for service providers to have that flexibility. So this builds up firstly the LSO, Presto Legato provisioning. So basically from the Cisco NSO, it's provisioning of the NIDs. The provisioning is not only of the Telia's network devices, but also Kvantel's e-access NIDs. we're then seeing that underlay is hugely important. And by the way, we have here some parts of this underlay are 4G, and so it's really important to be able to make sure that that service is up and running well. So we show here that you can do not only end-to-end performance monitoring, but also per segment performance monitoring. Because as we see in the next slide, let me show you here. As we see here, when we look at the SD-WAN overlay, the SD-WAN overlay is really the performance that the customer sees. But when there's a degradation of service, the service provider needs to look for the root cause. Is it their network? Is it the wholesale network? And so they need those tools. The end customer may not even notice it, because with the SD-WAN application, it may do steering, that if the underlay infrastructure should go down, it may steer all the traffic over the internet, and maybe no one even notices. But the service provider needs to have notification on that. So that's a very important part of it. And then lastly, it's VNF service chaining, which I think is really critical for the UCPE, to be able to show additional applications. So this just kind of summarizes what the various vendors did in this. OneAccess providing a NID, Nokia, Nuage providing the SD-WAN solution, RAD, the universal CPE with integrated NID, okay, to host the value-added functions. Cisco, the automation and orchestration using the standard Legato YANG modules. And actually, we'll talk about that in a moment. Those were actually downloaded just about 2 weeks ago from the MEF wiki. And that's an important part of this as well. And it's already part of a PoC.
Operational on both ends?
Correct. And so, to summarize this, basically we're hitting all the main things that have been a focus of the MEF over 2017. All the dynamic through LSO, on-demand, multi-carrier, SD-WAN, and so it really is helping to validate MEF 3.0 vision and 2017 innovations. So now we're going to switch to the demo portion of it, starting with Carl, who's going to describe the MEF LSO APIs and how that works. So now we're going to be switching to the demo portion of the PoC. Carl, can you walk us through the first demo, the LSO Legato-based provisioning of the underlay infrastructure, the EVCs as well as the e-access?
Absolutely, happy to do so. So what we wanted to show here is how to use the recently published Legato YANG modules to provision an EVC and also show in-flight changes to a bandwidth profile. And what we really wanted to push on is that based on MEF's recent, or the MEF's recent publishing of the machine-readable version of the specification, the effort to do this can be significantly reduced. And by significantly, I mean that we were able to prove this or show this inside the 2-week time constraint that we gave ourselves for the demo. So what we did was that we actually, using the YANG modules provided by the MEF, we looked through what needed to be done here, and we saw that, of course, based on the data model or the information model from the MEF, there are 3 important stones or 3 important parts of the Legato model. You need your UNI definitions, you need your bandwidth profile definitions, and you need to tie them together in an EVC. So we are provisioning that service, doing those kinds of steps, and then we're showing an on-the-fly update of the bandwidth profile using these standard models. So the actual top-line flow here is that we do what the Git people would call clone, meaning we download the YANG files, we download the machine-readable files. We load them into our orchestrator, and we get a set of northbound interfaces generated. So the ones that we are showing here during the demo is a REST interface, a netconf interface, and a command line interface. So the cool thing with the choice of YANG here for the machine-readable definitions is that it's technology agnostic. So we wanted to show that you get a whole variety of ways of interacting with the Legato interface, kind of as part of the package. And also, of course, you need to be able to not just to take orders on the Legato interface, you also need to actually do kind of Legato to device mapping. So at the heart of the demo was that we wanted to show that now that we get the northbound interfaces or the legato interface for free, the actual meat of a demo like this is to show how fast we can do a legato to device mapping, including an internal Presto interface. So without having seen one of these boxes before, the OneAccess box, we were able to, inside of 2 weeks, to write the decomposition logic to be able to create that uni, create the bandwidth profile, tie it together in an EVC, and also update the bandwidth profile on the fly. So this is the proof point that we can compress the time it takes from a blank slate into full legato the features, and also actually supporting a vendor that we hadn't seen before. So what we were looking at here, and you can actually see that on the screen here too, is that we are looking at the publicly available GitHub site where the MEF has an actual public repository called MEF-Git, where they actually publish then again their Yang modules. So this is freely available to anyone to download and actually load into the system. So that's what we did. And again, we found, as you can see here, 3 main modules. You got your interfaces where you define your uni, you have your globals where you define your bandwidth profile, and the services where you tie them together into an EVC. And Yang then again drives the northbound interfaces. So when we switch over to the demo, we'll show you some of the REST interface, and we'll look briefly on the CLI. And we then built the service decomposition. And what's really cool here is that now that Yang is a formal definition of the API, it provides or allows for full flexibility, full create, read, update, and delete options for instances of services running in the network. So things that used to be fairly complicated, i.e. describing how you do an on-the-fly bandwidth upgrade, is now a single operation towards the API. So before we head into it, I just wanted to show you that we're going to use RESTconf and CLI. We're going to have 3 unis. One is the uni Kvantel, that's located in the Kvantel network. We have 2 unis in Telia 1 and 2. We have a bandwidth profile called Bandwidth Ethernet LTE, and a single EVC for this demo called ELAN. And what's really cool here is that these modules actually use something called Yang leaf refs, which are referential integrity pointers, making sure that there's actually a uni for the EVC, and that the unis also point out existing bandwidth profiles, really reducing the amount of work for the programmer that wants to use their programmatic APIs to deploy this. And so the steps that we do here, we look at, make sure that we have an applicable bandwidth profile, we assign the new bandwidth profile from an EVC, and we commit the changes. And then, of course, the core of the orchestrator is to decompose these proposed changes into a set of parameters that we can send off to a device like this. And as a matter of fact, we do this protected by what we call a 2-phase commit-based transaction, which is kind of an either-or way of doing this. So either it entirely succeeds in the network based on the feedback from the network, or we're going to roll back to where we were before, significantly lowering the bar again for someone who wants to treat their network as a database. All right, so if we move over here, and we'll take a look at what this looks like. So, as I showed you, here is the global or the publicly available specifications. And one of the ways that you may want to look at this is you take these machine readable files and you turn it into something that looks like this, which is a means of actually using these Yang files to document what you need to do. So if we do an expand all here, we can see that these are pretty ambitious specifications. You get the full breadth of the MEF services provided to you in this data structure here, that is actually then constitutes the actual API that you're using. And the way we show this today, or show this here, is that we are trying to use, of course, the tools that the target audience likes. And we understand that most people that actually work in what the MEF called the business applications, which is normally an order manager, they prefer integration using REST with a JSON encoding. So one very cool thing that we can see here is that by using Yang and the appropriate mapping into a standardized RESTconf interface, you can actually query the orchestrator. You can query the SOF to say what are the models that you actually support. So what you can see here is that this orchestrator is telling me, or us, that it actually supports the MEF legato interfaces, the unit definitions, the EVC definitions, and also the bandwidth profiles here. So we're good to go with the actual services. Now, we can then start looking at the composite parts, right? So first of all, we can make sure that we actually have something running in the network, or we have a definition of a bandwidth profile. So you can see here that we have pre-provisioned two bandwidth profiles, one called bandwidth Ethernet LTE, one called bandwidth Ethernet LTE2. And again, all these data structures are directly derived from the machine-readable files published by the MEF. So there's literally no coding done to provide this stuff here. And then we look at the interfaces to make sure that we have the unis that we need. And the orchestrator will tell us that yes, we have the unis that we need. We have uni Kvantel, we have uni TeliaCompany and uni TeliaCompany. And of course, the finishing touch is to look at the services here and make sure that we have the appropriate EVC provisioned in the network. And you can look here again at the standard model to say there's a single EVC called ELAN. And it actually points out down here, again, using that referential integrity, existing units, in this case, uni Kvantel 1, Kvantel 1 and uni TeliaCompany and uni TeliaCompany 2. And of course, we want to tie this together with that kind of EVC. Yeah, I think that we'll leave it at that. And that kind of wraps up the presentation.
All right, great. Thank you very much, Carl.
Thank you.
So Alistair, can you address the Nuage SD-WAN portion of the PoC?
Absolutely. So what we see here, built upon the underlay and the foundations of the service, is the overlay view of the SD-WAN service that we've built. So here in the two pink boxes for Norway and Sweden, we've deployed our NSGV software, which is a virtualized instance of our SD-WAN CPE running on top of the RAD UCPE platform. Sitting next to this, we also have a virtual firewall from another vendor, and we can perform local service chaining either directly in the RAD CPE, or it can be service chained by the Nuage CPE instance as well at the SD-WAN layer. Sitting on these sites, we have a couple of different services. In Norway and over there in Finland, we have both a layer 2 segment and a layer 3 VPN segment, and in Sweden we just have the layer 3 segment. So we're delivering different services across the network, all overlaid on top of the transport infrastructure, the internet and the Metro Ethernet service. And we're delivering them to different sites as we need to. These systems are tunneling across here, and in each tunnel, over the two different underlays that are available to them, they're measuring the overlay service performance, allowing us to understand the characteristics and the behavior that the underlay network is offering to the overlay. If we have multiple classes of service available, we will test and measure the performance of all of those classes of services. We can then define as an enterprise consumer of the overlay service the behavior of our applications, or how we want to map those to, say, a platinum, gold, bronze, or silver class of service, and define criteria which say, in the event of degradation, we might choose to switch the platinum services to another path. We might also choose to directly offload some traffic, such as that destined for YouTube or Salesforce or other cloud environments, directly to the internet, bypassing the need to go to a headquarters location.
So this is dynamic steering of traffic.
This is dynamic steering of traffic by application. Over here in Finland, in addition to the virtual CPE instances, we have a Nuage physical CPE instance. This system is also acting as a UCPE, but where we deploy a third-party firewall from another vendor as a VNF inside the SD-WAN CPE. So this is consuming the functionality of the firewall within the CPE, rather than sitting as a virtualized function next to another virtualized function. So two different UCPE models, both offering very similar types of functionality, deployed in parallel on the same customer service. Finally, all of this is managed by the infrastructure that we've deployed in another lab facility, actually itself using an SD-WAN service to backhaul the traffic to a Nokia facility in Portugal, where we have our management and control infrastructure as well as the user-facing front end, where the user can interact with their services. So actions that a user might take when they're managing an SD-WAN overlay, obviously we can see here the view of the CPEs that are up and in the green, and a site that's in an alarm down here in Portugal. They might want to drill into their application discovery and see the traffic that is being traversing the network broken down by applications. We can see here that we had some TCP and UDP streams generated by test equipment, in addition to some applications that we use deep packet inspection to classify and recognize. These are the application types that we can associate to SLAs and define SLA criteria for them, like lowest latency, lowest packet loss, to move that traffic dynamically to the underlay that best meets their needs. As a service provider, I can go beyond what the enterprise can manage and see, and I can define services like those SLAs, assuming that my VPN works. There we go. So I get a more granular view as a service provider, where I can see here, for instance, in the dashboard, I can see the granularity of those alarms that were collected earlier from that site that we saw an alarm. And I can go much more detailed into the CPE management, whether it's physical or virtual. I can take advantage of things like real-time inventory of the CPEs, identifying whether I'm running as a physical network function or a virtual network function, what type of device it is. So here we can see a physical system, and here we can see a VNF. So we can see that this is running on top of a KVM hypervisor. So this is one of our NSG-Vs running on top of the RAD system. We can then go into a definition of applications and SLAs. You can see here we have an application group which has a couple of sample applications in it, and we can associate a network performance measurement service with that, where we're running a performance monitor, which in this case is sending one probe every second in a service class of H to measure the performance of the underlay. And we can then define actions that will automatically be taken by the network if there is an SLA violation. So all in all, what we have here is an end-to-end service across physical and virtual infrastructure delivered on top of multi-vendor underlays and CPE equipment.
Thanks a lot, Alistair.
Thank you.